Okay, and number 14, here I have negative 2s to the minus 3 times t, and then I have 7s to the minus 8 t to the fifth. Well, the first thing I notice is that there is no exponent outside these parentheses, so this expression right here is not raised to any power. So we can eliminate the parentheses. So this is equal to negative 2 times s to the minus 3 times t times 7 times s to the minus 8 times t to the fifth. Okay? So what we're going to do is we're first of all going to multiply the negative 2 times the 7 together. So that's going to give us negative 14. Okay? Now I'm going to multiply s to the minus 3 times s to the minus 8. So if I have two bases, in this case s and s, that are multiplying each other, I add the exponents. So I say to myself, negative 3 plus negative 8. What's that give you? I'm hoping you're going to say negative 11. So this becomes s to the minus 11 power. Okay? Then I go for the t's. Okay? So here I have t, and if there's no exponent, we assume the exponent of 1. So I have t to the first times t to the fifth. Well, 1 plus 5 is 6. So this becomes t to the 6. Alright? So the only thing I have left to do is to make this exponent, this negative 11, into a positive. So think of this expression as over 1. Okay? So now I'm going to move this s to the minus 11. I'm going to move the s and its exponent into the denominator. Alright? So now this becomes negative 14 t to the 6 over s to the positive 11. Number 15, here I have negative 4 times m, and then the quantity m times n squared raised to the third power. So the first thing I'm going to do is to eliminate the parentheses, recognizing, of course, that m has an exponent of 1. So here we go, negative 4 times m. Now, this is raised, this thing in yellow, this expression inside the parentheses, is being raised to the third power. So when you raise a power, when you take a power and raise it to a power, you multiply. So I go 1 times 3. So this becomes m to the third. Then I have n squared raised to the third power, so that's 2 times 3, which is n to the sixth. Alright? Now all I have to do is take these two m's and multiply them together. So m to the first times m to the third is m to the fourth. So I have negative 4 m to the fourth n to the sixth. Again, taking a multiplication expression, raising it to a power, you multiply the exponents. Okay? Number 16. So here I have 4b raised to the second power. So this is recognizing that it is 4 to the first, b to the first, raised to the second power, over 2b. So when you have a multiplication expression being raised to a power, you multiply the exponents. 1 times 2 is 2. So we have 4 to the second power. Again, 1 times 2 is 2. So there's b to the second power over 2b. Now, square the 4. So 4 times 4 is 16. 16b squared over 2b. By the way, this b has an exponent of what? Hopefully you're going to tell me 1. Alright, so 16 divided by 2, 8. Now, looking at b squared divided divided by b to the first. When the bases are the same, so I have a b and a b, when the bases are the same and dividing, you subtract their exponents. So I'm going 2 minus 1. So this becomes b to the 2 minus 1. And 2 minus 1 is 1. So that's equal to 8b to the first. In turn, this becomes 8b. And number 17. So, using my rule of quotients, I'm going to actually do two divisions. I've got x to the negative 1 divided by x to the third, and I have y to the minus 2 divided by y to the minus 5. Using the rule of quotients, so I have x, so I have minus 1, negative 1, minus 3. So you subtract the bottom from the top, and here I have y minus 2 minus a negative 5. So minus 1 minus 3, negative 1 minus 3 is negative 4. And this becomes y minus 2 plus 5. Two negatives right here make a positive. 2 plus 5. So this in turn is x to the minus 4, y cubed. Okay? Think of this as over 1. And now all I have to do to make this exponent positive is put it in the opposite part of the fraction. So this becomes y cubed over x to the fourth. Oh, and there's a 1 there, which in turn becomes y cubed over x to the fourth. And that's your final answer.